Welcome back, class. Now what we're going to look at is how to translate inequalities from word problems. These word problems, some of you may have seen before. I took them directly from your study island, but they are good examples of how we're going to dissect these word problems and pull out really the important and key information. So, lots of words up here, and a lot of people don't like reading these word problems because a lot of times they don't know what to look for. Well, the great thing about math questions is typically the question is typically near the end of the actual problem. So in this case, we're going to set up a word problem, we're going to set up the inequality, and then we're going to solve it. So, basic information that I see here, I see that I'm talking about Chris, and he's typing at an average speed of 50 words per minute. That is very key and vital to our information up here. So I'm going to underline that information, and this per minute is going to come back in a second. Okay? Now, he's already typed 1,750 words. He's already typed that of his final paper, and his paper has to be more than 4,250 words. Okay? And this was one, again, that I pulled off Study Island. So they're giving you a choice of four choices to come up with which one is the actual inequality. But in this case, we're actually going to set up. We're going to dissect it and give it, we're going to translate it ourselves. That's what they're saying here, which could be used to solve for x. And this is important, the number of minutes it will take Chris to write his paper. Now, that is probably the most important thing we're talking about here. Our variable represents the number of minutes to type this paper. So, using that information, the first question that I would always ask myself is, if that's my variable, what am I attributing to this variable? What goes along with that number of minutes? I look back through what I underlined in the problem, and the first thing I do see was the first thing I underlined. 50 words is what Chris can type per minute. This word per physically means to multiply. It is a rate. So in that case, what am I going to do if I had 50 words per minute? Well, that means I have 50 times the number of minutes I have here, or a 50x. That's where I'm getting this 50x from. Furthermore, what I have to look for now is he has already typed 1,750 words. Now, this typically gets confusing for some students. So I'm going to drop down, I'm going to bring that as 50x for a second. Okay? What I'm going to do then is I'm going to figure out what's happening in the problem. In this case, I'm talking about Chris typing. So one side of my inequality is Chris typing all of this stuff. Okay? And then the other side of this is what else is happening in this case. Chris is typing all these words over here, and on the other side I have the total words, which is what he's being constrained to. In this case, the paper has to be more than 4,250 words. So, which side of this, Chris is typing, or the total words, has to be the greater case in this sense? Well, this is Chris's typing paper. That has to be greater than the total words because it has to be more than 4,250 words. So from here, I know my inequality is going to be a greater than sign, and I know it has to be greater than 4,250 words. Now, here's the other question then. How do you apply the 1,750? Well, he already typed it. So, which side of this is Chris typing on? Well, if I dissect this correctly, Chris is typing on this left-hand side, so that means that 1,750 would go to that left-hand side, and then, because he already typed it, it would be a positive 1,750. Now, a lot of times, my students, they get confused, and a lot of times they say, well, hold on, shouldn't we subtract 1,750 from the 4,250? Well, actually, yes, that is true. And in solving this, a lot of times they want to go through and say, well, that should be minus 1,750. But what would you do to solve this? So go through, if you're solving this problem, to actually balance this inequality, wouldn't you add 1,750 to both sides? Well, think about it. If you're doing that, isn't this total word, this word count that they said that has to be more than 4,250 words? Isn't that now getting higher? That doesn't make much sense in that case then, that the word total would get even higher. So in this case, we shouldn't be subtracting in here. We should actually just be adding the 1,750. So now the solving is just as we've done before. Subtract 1,750 from both sides. So I know 1,750 minus 1,750 is 0. So I have a 50x is greater than, and now it's just a simple subtraction problem. If you have to borrow, come over and borrow. So I have 0, 0, 5, 2,500, and then divide by 50. And this is nice and easy. What I like to do is, obviously 50x divided by 50 is just x because that was a positive. My inequality sign stays the same. And then what I tell my students is if you're dividing by any factor of 10, or any multiple of 10 I should say, cross out as many zeros on top and bottom. Now it's 250 divided by 5, which we know would just be 50. So x is greater than 50. Here's another example translating. This time we're talking about someone who's a nutritionist, and they want this person to consume less than 2,027 calories per day. Now, the person that is in question has already eaten 1,570 calories in this day, and they want to eat some fruit bars that are, in this case, 51 calories each. This is good for if you're maintaining a diet or whatever. In this case, again, this was a study island question, but here we're looking for X, the number of fruit bars Ralphie's father can eat without going over. This is the trick. You cannot go over that calorie allotment, which is that intake of 2,027 calories. Well, here's the information that we have. Here's what we know. We know that X represents the number of fruit bars. So again, what value in this word problem attributes to the number of fruit bars? Which value up there actually goes along with it? Well, here I look directly at the fruit bars are 51 calories each. So a lot of times I'll ask my students, hey, well, if you have one fruit bar, how many calories is that? I'll say 51. 2 fruit bars, 102. And they keep going because we know that if this each is a rate, right here, that means that we would have 51 times X, the number of fruit bars that we're talking about in this case. Okay? Now, here again, I'm going to drop this down. Drop down my 51X, because now I'm going to define what's on both sides of this inequality. Well, one side is what Ralphie's father can eat. So this is his eating over here. It really is Ralphie's father's diet. And then on the other side are the total calories. So this is what is he eating. The other side are the total calories. And we already know what the total calories are. The total calories that in this case are 2,027 calories. Now we just have to figure out the relationship. In this case, we want him to consume less than 2,027 calories per day. So, should Ralphie's father's diet be greater or less than their total calories? Well, in this case, we know by definition in this case, in our problem, it is less than. So in our inequality, we're going to keep that less than as well. And now we just have to figure out how to work in the 1,570 calories that were already eaten. Well, we already know, based on our last problem, that if it was already eaten with Ralphie's diet, that should be added in to this inequality. And now all we have to do is go through and solve. So in this case, we know we have to get our 51x alone. So we subtract both sides by 1,570. The 51x will drop down. So I'm going to drop in my 51x. It is less than. And now I'm just going through and subtracting 2,027 minus 1,570. And I get 457. And now, simple division problem. Divide by 51. because that 51 was not a negative, my inequality sign is going to stay the same. And then 457 divided by 51. And again, this is one of those calculator problems that I tell my kids, you know what, you guys can go through and use a calculator if you want. Becomes a mixed number, 8.9607, blah, blah, blah. Now that's our mathematical answer. So back to the question. How many fruit bars can Ralphie's father eat? This X represents the number of fruit bars that he can eat. Well, X is less than 8.9607. My kids will always ask me, can I round that up? Well, in this case, can you? Based on our unit, we can't. So although this may be a mathematical answer, real world answer here would be Ralphie's dad can eat less than or equal to 8 fruit bars, because we would have to round down in this case in order to never go over the total calories is 2,027. So I hope that was informative. Make sure your notes are good to go. There is no form for this one class, so you are good. Just show me your notes tomorrow that you watch this video.